am Rashi Mandal, a third year petroleum engineering student from MIT World Peace University, Pune.
And I'm Vidhi Palodia, a fellow petroleum engineering student from Pandit Deendayal Energy University, Ahmedabad. We're both going to be your hosts this evening. Good morning to all the folks who are joining us from USA. Good afternoon to those who are joining us from Europe and Middle East. And good evening to those who are joining us from India and Far East. A very warm welcome to one and all present here. We are all gathered here for today's IADC's event, first webinar on hurricane and cyclone.
I would like to remind everyone to keep their mics on mute throughout this session, and all questions can be written in the chat box. Everyone is requested to maintain the decorum of this meeting.
Before beginning with this session, we'll have our traditional auspicious lamp lighting ceremony on a virtual platform. We now request Mr. O.P. Singh, Chairman of IADC South Central Asia Chapter and Director of Training and Field Services of ONGC, who is our chief guest for this webinar, to do a virtual inauguration and lighting of the lamp. Thank you, Mr.
Go ahead.
Mr. Om Prakash Singh has taken over his charge of Director of Training and Field Services on 1st April 2020 upon the superannuation of Mr. Naveen Chandra Pandey, a mechanical engineer with more than 32 years of experience. Mr. Singh has built a deep industrial understanding and proven management experience across the technical and commercial roles he undertook during his career. Mr. Singh has a distinguished track record as a drilling engineer and has demonstrated dynamic leadership and vision as he progressed through various roles with the company. He is well versed with national and international exploration and production business and carries extensive experience in offshore and onshore operations. He has the vast industry knowledge and global business experience. He has played major roles in handling the challenging deep-water drilling projects in India and overseas projects in Vietnam, Iran, Qatar, and Brazil. Mr. Singh's tenure as head Nava supply base has been very impressive. In challenging conditions, he exhibited a leading role with enthusiasm, clarity, and discipline, thereby transforming the performance of the Nava supply base. With a focus on performance metrics and a continual drive for excellence, Mr. Singh superheaded Tripura Asset as the asset manager. During his tenure, the asset made significant improvements as he was instrumental in several initiatives and enhanced the asset's overall performance by fast-tracking projects and synergizing resource mobilization and its utilization. Mr. O.P. Singh has an open-minded and forward-looking approach with a firm belief in teamwork. We now request Mr. O.P. Singh, our chief guest, to give the inaugural speech for the webinar.
Sir, kindly unmute yourself.
Okay. Thank you, Vidhi, for your good words. Distinguished guests, esteemed musicians, dear colleagues from IADC fraternity, ladies and gentlemen. A very good morning, good afternoon, and good evening to all of you, depending on your location. It gives me great pleasure to be part of this tremendous initiative undertaken by IADC South Central Asia chapter on hurricane and cyclones. This aspect of offshore phenomena holds the key to safe operations and holds greater focus in view of recent super cyclone Tokte, which hit western offshore of India with such ferocity. Friends, IADC fraternity together fought the most deadly pandemic and supported each other in continuing the business by exchanging ideas and sharing experience in spite of enormous challenges posed by COVID-19. Now, economy is recovering from challenges of second wave and vaccination drive has boosted our confidence. Although threat of third wave is looming, but again we will become support system of each other and sail through any challenges being posed on us. Unprecedented cyclone in western offshore has jolted us, and repeat of the event cannot be ruled out. A clear understanding of cyclone and hurricane development, its intensity, cause, and effect is paramount for all our stakeholders. It's very gracious on the part of Mr. William Reid, ex-director, National Hurricane Center, USA, with more than 40 years of experience in hurricane meteorology. We look forward to hear his vast experience with US here in India. I would like to extend my heartfelt thanks to Mr. Mike Dubose, who is always very forthcoming to support SCA chapter, Mr. Arun Karle, who is guiding force for us, and IADC SCA chapter colleagues who are always ready to delimit the limitations. For taking this great initiative and understand that this will be a part of three-part series on the subject. It is also very heartening to see next generation oil and gas industry budding leaders conducting the event, which will go a long way in their quest to add the next billion barrels in safe, sustainable, and environment-friendly manner. With this, I wish this session a great success in achieving its desired objective. Please stay safe from the pandemic as it's not still over. Thank you. Thanks to all of you.
Thank you so much, Mr. Singh. We would now like to invite Mr. Mike DeBoer, Vice President IADC Houston, to give the opening remarks. Mr. Mike DeBoer served as IADC's Vice President, International Development. Mr. DeBoer began his career with Rowan Companies at an entry-level position of a roastabout in the Gulf of Mexico in 1978. He worked offshore for the next 17 years at positions including driller and OIM. He moved into onshore-based management and accepted positions with increasing level of responsibility in the UK, Aberdeen, and Nova Scotia, all with Rogan. Mr. DuBois served as Vice President of Drilling Operations for Southeast Asia, where he oversaw offshore operations in Southeast Asia for He retired from Rogan in 2013 after 35 years with the company. Mr. DuBois holds a Master of Science degree from the University of Aberdeen. Sir,
Yeah, Mike, go ahead with your opening remarks.
Yes, hello and everyone, and welcome Mr. O.P. Singh, distinguished IADC South Central Asia chapter officers and honored guests, It's a pleasure to be with you as we embark on the first of a series of webinars that look at severe weather events that have impacted our industry, particularly offshore of India. The most recent cyclone took a heavy toll on both rigs and platforms, but more importantly than that is the loss of life that this event imposed. As leaders in our industry, it is incumbent upon us to listen and to learn from these events and to work to ensure we are implementing practical mitigating measures to safeguard against such events in the future. We appreciate you being here today, and we're very privileged to have a very distinguished guest speaker. I'm looking forward to hearing from Mr. Reed, and I'm sure that we will all gain from his experience and insight. I am delighted that we have the participation of the students from two of the India universities today moderating the event for us. Finally, I wish to acknowledge the role of Mr. Arun Carley in organizing this webinar today. Arun, as most will know, has been a long-serving member of the SCA chapter and a fine ambassador for IADC, and we certainly appreciate his efforts. Thank you very much and welcome.
Thank you, Mr. Mike Dubose. We now request Mr. William, a speaker for the day. Bill Reid currently works as a consultant with Texas A&M Galveston and others on applied problems in meteorology. Bill retired in 2012 after 35 years career with the U.S. National Weather Service. At the time of his retirement, he had been director of National Hurricane Center in Miami from 2008 to 2012. Prior to his serving at National Hurricane Center, Bill was a meteorologist in charge of the National Weather Service, focused office in Lake City, Texas from 1992 to 2007. Severe storms and flash flood programs leader at the agency's headquarters in Silver Springs, Maryland. Forecaster at National Weather Service Forecast Office in Fort Worth and San Antonio, and research meteorologist in the National Weather Service Test and Evaluation Division in Sterling, Virginia. Bill served 5 years as an officer in the U.S. Navy, where he flew with the Navy Hurricane Hunters out of the Jacksonville, Florida. Was a forecaster in Keflavik, Iceland, and was officer in charge of the Navy Weather Detachment of Kingsville, Texas. Bill served as a camera hurricane expert with KPRC TV Houston from 2012 to 2015. Bill earned the Bachelor's of Science degree and Master's of Science degree in Meteorology from Texas A&M University. He is a Fellow of American Meteorological Society and has served as President of the National Weather Association. Significant awards include the Neil Frank from the National Hurricane Conference in 2015 and the Robert and John Simpson Award from the National Tropical Weather Conference in 2020. Now, without any further ado, I request Mr. Bill Reid to continue.
One more reminder, if everybody could mute, we won't have the feedback on this line. It's a great pleasure and an honor to be able to talk with a group of people that are trying to learn a lesson from what was a terrible event in your cyclone that hit on the west coast of India. It reminded me, I actually followed it because it was so unusual, the track that it took. I only found one other storm in our database that even remotely resembled that, and that was like 30 years ago. But it did remind me that these cyclones and hurricanes, the ones that are extreme, are almost always unprecedented when you talk to people that are impacted by it. The latest version of that I would parallel to that I would use for what happened in India was we had a Hurricane Sandy back in 2012 that took in the last 150 years, there have been no tracks anywhere remotely close to the track that Sandy took when it did extensive damage in the mid-Atlantic region of the East Coast of the U.S. So it is very important to do what you're doing, which is to learn and adjust how we respond to these very rare events. So I'm going to share a screen there and just holler if something goes wrong with this and we'll fix it. And okay. There we go. All right. I'm going to be talking, I was asked to talk about how the U.S. Hurricane Warning and Forecast System actually works. And having been in charge of that for a while, I'm pleased to be able to do that for you. First, a little bit about the tropical cyclones themselves, a little science, if you will. Anywhere around the globe, these are kind of conditions we look for. Ocean water temperature, right? The heat of the ocean is the driving energy that fuels the tropical cyclone. And researchers have found that around the value of 27 C is the minimum warm temperature you need to form and sustain a significant tropical cyclone. In this picture that I'm moving the mouse over here that shows the reds and oranges was August 1st sea surface temperatures in the tropical Atlantic. Anywhere where the bright oranges and dark through dark reds are, the water is warm enough to support any intensity of hurricane this time of year. And it kind of delineates what the effective area we looked at for formation, anywhere from the coast of Africa through the Caribbean, Gulf of Mexico, and Southwest Atlantic Ocean in our peak of our season. For us over here from August, 1st of August through October is when 90% of all the hurricanes form, even though our season usually runs from the 1st of June to the end of November. The next element that we need is a convectively unstable atmosphere. And what that means, it's capable of forming the deep towers of cumulus clouds and showers and thunderstorms that are a marker of an area of disturbed weather that eventually becomes a cyclone. And this is a satellite picture of just such an event. And it's pretty easy for us now in the satellite area to determine if we've got a convectively unstable atmosphere by having the occurrence of these showers and thunderstorms. Somewhat related to the unstable atmosphere is needing a moist mid-level in the troposphere in the 3 kilometer to 6 kilometer range. When the air is moist like that, the rain falling through it doesn't evaporate. You don't get cool, dry air sinking to the surface, which would, in effect, negate the buildup of thermal energy. Somebody's unmuted. Please mute. When the air isn't moist in the mid levels, you get a lot of evaporation and downdrafts of cooler, drier air, which inhibits the development of a storm. So very important to have that criteria met. Low values of vertical wind shear. This diagram here is what I'm going to use to try to give you an idea what we mean by that. In a favorable environment for development, the winds don't change much with height from the surface through the tropopause, and this is just a zonal wind or east-west component. And generally speaking, you have the easterly trades down low and weaker winds even aloft. You don't have strong wind shear. In the Atlantic hurricane basin, this is indicative of the atmosphere we get during a La Nina event in the Pacific. And we had such an event last year and had a record number of storms. On the other hand, when you have stronger than normal trade winds at the surface and a westerly component of the wind aloft, that creates a shear of differential in the wind from the low levels to the high levels, and the storm has trouble maintaining vertical consistency as it tries to develop, and it tends to inhibit develop. This is the kind of pattern we normally see when we're in a El Nino condition in the Pacific Ocean. A pre-existing disturbance, there has to be something to begin with. Just it's not going to form out of high pressure dry air. It's going to form out of a trough of low pressure or a concentrated area of convection. And again, this picture here, this is an area of disturbed weather. In the peak of the season, now through October, the place we look for these disturbances to form is over the near equatorial regions of Africa, but with interactions from the African monsoon and low pressure areas firing off south of the high over the Sahara Desert. These are called easterly waves by our scientists. And about every 2 or 3 days this time of year, an easterly wave moves off the coast of Africa. And obviously, very few of them actually develop, but they're the ones we look for developing the hurricanes further downstream as they move across the Atlantic. And then one other key is they tend to need to be a distance away from the equator to get the vorticity or spin induction and get them rotating in the low pressure systems. It's very rare to have one form south of that boundary, and that's true around the globe. It's the same basic conditions for tropical cyclones in any of the basins that have them. In red here is a caveat. We find these conditions quite often, and yet no storm forms. So we're still learning about the various functions that trigger the eventual genesis of a tropical cyclone. And we're making major strides. 10 years ago, we rarely had a good forecast in advance out of computer models for a developing tropical cyclone. And much of the time now, we get a pretty good idea from the models. As much as 5 days out that we have potential for a tropical cyclone. Major gains, but we have work to do still. And then we have the intensity issues. Every basin around the globe has worked out their own method for coming up with a fairly easy categorization to present to people, easy to understand. In the Atlantic, Eastern Pacific, and Central Pacific basins, we've adopted the Saffir-Simpson hurricane scale. Dr. Saffir was a structural engineer, and Dr. Simpson was director of the Hurricane Center back in the 1960s and early 1970s. And they came up with a scale after Hurricane Camille. Remember, this was still where people were getting warning information, a lot of them over radio. We weren't having graphics and stuff, and we didn't have good satellite or anything back then. And they needed a shorthand way to get into people's mindset what the relative risk of each storm was. And what they came up with in these categories 1 through 5 was the same storm came across the same location at increasing intervals of category, there'd be roughly an order of magnitude more damage caused by those storms. That was the engineering component. And that's how we came up with the 1 through 5 scale that we use there. Storms form before the hurricanes, and a tropical storm is in the 34 to 64 knot range, and the tropical depression is any rotating warm core system, closed system, and below the 34 knot cutoff for naming a storm. And damages do occur from these, so it's primarily from the rainwater flooding that we get tremendous damage from even the depressions or storms that may stall over land. The category 3, 4, and 5 are called major hurricanes. And one of my pet peeves is I'll hear someone on TV or just talking with people saying, oh, it's only a category 1, I'm not going to worry about it, or it's just a tropical storm. There is no such thing, and that is the one drawback of using a scale that implies less to more is that people tend to downplay the low ends of scales in just about any type of disaster warning system you come up with. Okay, on to our operations. The mission of the National Hurricane Operations is number 1, you give the citizens information through warnings and forecasts that can prevent loss of life. And we've become very successful with that, and we're gaining on success on that around the globe. Provide citizens information that reduces damage. Give them enough lead time of what the risks are and educate them to ways to prevent the damage, but we can reduce the losses from these hurricanes. And lastly, information that reduces economic impact. This is where many industries can take actions that will reduce the amount of downtime they might have or other economic losses the storm could occur. The start of the hurricane program for the United States emanates from the National Hurricane Center. This is a picture of our facility on the campus of Florida International University in Miami. It's a hurricane-hardened building. It was designed, interestingly enough, in part by Dr. Saffer. I would write out any hurricane that Mother Nature could throw against me in this building. It's quite impressive in its design. It also houses the local forecast office for South Florida, the National Weather Service Miami office, and it was built in 1995. And the way technology changes, it's already getting strained to handle the major changes in technology that have come down the science since then. This graphic on the right here is a map showing our areas of responsibility. The hurricane responsibility is foremost in the Eastern Pacific and the tropical Atlantic, though we cover the entire Atlantic for tropical cyclones in the entire Eastern Pacific. We also back up the Central Pacific Hurricane Center, which is out in Miami or in Honolulu, Hawaii, in case they have a failure of operations there, we can back them up. Marine weather forecasts are done again for the tropical Atlantic and tropical Eastern Pacific, and they back up the entire Northeast Pacific and North Atlantic in case the office that puts those out ran into difficulty. So it's a wide area of responsibility that we cover out of that office, and modern technology allows us to do that quite well. Inside the office, it's about 50-person operation there. The unit that most people are familiar with, obviously, is the Hurricane Specialist Unit. These are the folks that actually issue the forecasts and warnings on tropical cyclones at the Hurricane Center. It consists of 10 hurricane specialists, most of whom have an advanced degree in meteorology with specialization in the tropics, and a supervisor we call the branch chief, who is also qualified to be a hurricane specialist. They work around the clock during the hurricane seasons of the Eastern Pacific and Atlantic, which run from May 15th to November 30th. And we have 2 specialists on per shift. And if there's a lot of activity in a big year like last year, we sometimes can augment by bringing people in on overtime to cover all the storms. Once we're out of the season, we still have a specialist assigned every day to monitor for developments in the tropics outside of the season. It's rare, but it does happen, and every month of the year has seen at least one occurrence of a tropical cyclone in the Atlantic Basin. But the predominant work of the specialists in the off season is study what went on in the previous season, propose and implement changes to how we operate based on what we learn, and also to study the cutting edge research to come up with new ways of doing the forecasts that can improve our forecast skill. We do extensive verification of the forecasts that were put out, including verification of the models that we use to make that. And it gives us added intelligence going into the future seasons on how to use those models. And a lot of time is spent doing outreach and education. The formal requirements, we educate meteorologists within our area of responsibility throughout the Caribbean and Central America in how we operate. And we try to do our emergency management colleagues in the coastal counties in the U.S. through education and outreach. A group that hardly anyone knows about, but is probably very important for folks in your line of work, is the Tropical Analysis and Forecast Branch. These folks are operational around the clock, around the year. They put out the winds and seas and weather forecasts out to 5 days across the tropical Atlantic and Pacific. On any given day, around 100 products are actually produced, mostly via computer with forecasters modulating the database that produces them. During a tropical cyclone, they augment the data coming to the hurricane specialist, the Dvorak technique, which is a satellite intensity estimator that it takes a fair amount of intelligence and work to put it together, and that's what part of their job is. Recently, they've begun issuing these type of products graphically to give people an idea of what the wind and wave issues are of a pending tropical cyclone. And this is a forecast map of a hurricane coming into the central Gulf. The color shaded areas are the wind speeds in knots, and the contours are the wave heights in meters at a particular forecast time. And feedback has shown it's a highly used product for people offshore. We also have a storm surge unit. Storm surge is potentially still a #1 killer, and it's obvious to you folks in India. You've had some of the most horrendous tragedies and loss of life due to storm surge for having some of the same conditions that exist in the Gulf Coast of the U.S. That make them highly susceptible to storm surge. Most of the year, these folks are doing updates to the model basis with the new data and improvements to the modeling. But during a storm, they'll actually run operational runs of the storm surge models to give input to the advisories on where and how much storm surge might be expected at landfall. And recently, we've taken on learning how to do the storm surge within the Caribbean basin. So the nations surrounding the Caribbean that have a storm surge issue, we can begin to provide them help on forecasting their surge. Okay, a little bit about the forecast operations, show you some of the examples. Again, this was talked about a little bit earlier, but the forecasts are issued on a 6-hour cycle. These are this was arranged out through an international agreement long before I ever came into work. This is what we've been operating on at least since the 1950s. Within the World Meteorological Organization, the Hurricane Center is the specialized chief of the Region 4, which covers the Atlantic and Eastern Pacific Basin. And once a year, we meet with all the member nations and work through the changes and whatnot that we have there and how we coordinate the information we put out with information they add relative to their countries. As for the products that are issued, even if there's nothing going on in the tropics, 4 times a day, a 5-day tropical weather outlook is issued. And that highlights any chances for new development. It'll talk about any disturbances, and I'll show an example in a minute. The next order of business for the hurricanes is the issuance of the advisories every 6 hours. The advisories, it's actually the name we give the suite of text and graphic products that cover the existing tropical cyclone, and it's a forecast out 5 days. The times that it's issued are this is 5 a.m. and p.m. and 11 a.m. and p.m. Eastern Daylight Time for the existing storms. Once the forecasts are issued, there's this almost continuous amount of high-level decision support briefings where the director and the other members of the management team usually take these on. It occurs mainly for the landfalling storms. Same with supporting committees. Hurricane watches and warnings used to be the main thing that triggered action in the United States in the hurricane zone. It's taken a lesser role than it used to. It has its important issues, mainly some legal aspects of what actions governments are allowed to take is tied to the watches and warnings. By agreement with the member nations, we issue a watch try to issue one at least 48 hours before the expected onset of tropical storm force winds. We use tropical storm force winds as the nominal low threshold for which it becomes difficult to carry out preparedness actions and some evacuations. The warnings go out 12 hours later, which hopefully will narrow down the area that's under the warning due to increased accuracy from that 12 hours. for the same conditions. And the goal is the number one goal is to have a successful evacuation. The challenge has become many densely populated coastal areas require greater than 48 hours to evacuate. This is a map of the evacuation zones for the southeast Texas, where the Houston area here, the Galveston area, the very populated and industry-laden west side of the Galveston Bay, Galveston Island, and then over off this map here is another industrial complex of southeast Texas called Beaumont Port Arthur. The nominal evacuation time is 36 hours, but decisions need to be made as much as 60 hours if you have a Category 4 hurricane that might threaten the coast here. So before we even have a watch out, they're making decisions, and the briefings are done to convey just what that risk is, and get people to understand just how much uncertainty there still is at that time. I've come to learn over the last 25 years that most key decision makers, be it government or industry, use action timelines and the forecast onset of the adverse weather at the thresholds they're looking at, rather than following the watch warnings to time their decisions. Okay, here's an example of pre-storm products that come out of the Hurricane Center. It's a combined text and graphic. A section of the text pops up. You mouse over the graphic on the internet where the orange shading is, and this text will pop up and gives an explanation of what the risk is of development in the next 5 days from a disturbance where the X is, and this is the area, somewhere in this area where development has a 60% chance of occurring. And they also split it down to what the next 48 hours probabilities are and the overall 5-day probability. A yellow area like this one out here is less than 40% chance within 5 days. If we have an area that's expected to develop, highly likely it's going to develop and it's approaching land, in the past we had a problem. We had no mechanism to issue advisories there. We came up with a technique of beginning to issue advisories and calling it potential tropical cyclone. And then we issue an advisory just as if there was a tropical cyclone already underway. And this has proven to be highly successful. About 80% of the potential advisories we've put out since we implemented it have gone on to become tropical cyclones. So it's a good innovation. The text products used to, before the internet, this is all people got. These two products out here, this is one went to the public. Through a teletype network, the emergency managers, state governments, federal governments, and the news media got these products shortly after the issuance of them out of the National Hurricane Center. And as long as I've been working, other than format changes, these are the two products that conveyed the conditions of the hurricane coming through, approaching the United States. A public one, it was a plain text message that was designed for being able to read over the air and tell people what the conditions are of the storm and basically what would happen in the next 24 hours. The international product called the Forecast Advisory product is where you get the specific forecast points out 5 days and the size of the storm, the radius of these various wind speeds in 4 quadrants from northeast around the northwest. And from this, it's always done in this format. So in the early days, people would design little computer programs that would parse this data and plot the forecast for them. Now with the internet, they just take it from the internet directly. Most decision makers tell me this is short of the graphic product showing the where the storm will go. This is their most useful product. The tropical cyclone discussion put out by the specialist responsible for that storm gives a detailed diagnosis of the current condition of the storm, and then his forecast reasoning for intensity and track forecasts over the next 5 days. And if there's a confidence issue, usually they'll talk about higher than normal confidence in the forecast or less than normal confidence in the forecast, all of which can play into the decision-making process used by the end user. These are the key advisory graphics in the next couple of slides that I find people are using here. The one here on the left is called, for shorthand, it's called the cone forecast in there, but it basically shows the track forecast. Those are the dots here with H's, S's, and D's. So it gives you not only where the storm will be in time, but whether it'll be a hurricane, a storm, or a depression. And there's also M for a major hurricane if it's that, rather than specific numbers to account for the fact that we have plus or minus 15 knots of uncertainty in the intensity on average in the forecast of intensity. We also have the warnings and watches that are issued. Each country is responsible for its own warning. So Mexico would have issued the hurricane warnings for the Yucatan Peninsula, whereas we would have issued for the U.S. the watches on the Gulf Coast. And the area in white here represents an average error of the last 3 years of the track forecast, 70% of that error. So what it really tells people is what's the likelihood, what's the most likely path of the core, the center of the hurricane, out the next 5 days. It does not tell you how far the impacts may go out to the outside of where that band goes. And sometimes people misread this product as just what the impacts will be, which gets really narrow when you get down in the 24, 36 hour and less forecast. The cone is much narrower than the impact zone. Another very important product is one that combines a chance of exceeding tropical storm force winds, which is the shading, and the most likely time of onset of those winds, so you can know when you need to get your actions taken care of by, and then work backwards to see when you need to start some of your actions. Then there's the storm surge graphics. There's a snapshot that is still in the experimental mode, but will probably become operational, that gives a quick glance what the possible peak surges will be at various segments along the coast. And again, this is from that same advisory of a forecast of the storm to come here in Louisiana, but the impacts of storm surge are far-reaching, hundreds of miles to the east along the Gulf Coast. For people needing more detailed information, there's GIS applications where you can zoom into your community and see the estimates of how high the inundation might be from the storm surge. And then we have the rainfall and flooding graphics. These are actually produced by a center, a forecast center up in the Maryland area. It has a unit that specializes only in the forecast of quantitative precipitation. And flooding of rainfall is in the last 4 or 5 decades, more people, as many people have died from the flooding of rainfall as have had from storm surge. So we've started to emphasize the risk of flooding more in our forecasts. The Hurricane Center hits the high level people. We mostly hit the states and the federal level agencies in there. For local impacts, the forecast offices like the one I ran in the Houston, Galveston area, we're the ones that get down to the county and city level and the timing and impacts from the storms there, using the products from the Hurricane Center and then value adding the local information, and through conducting very detailed briefings of those officials as the storm approaches. Just one tidbit here, we survey the public, since they're our end user, our primary target audience, of how they prefer to get their information. And when there's not a threat of a hurricane, for example, the internet or social media is the number one source. But once we have a threat of landfall, the dominant source people go to is their local television station, secondarily the tropical or the Weather Channel in Atlanta, followed by local officials, and then the internet and social media. So all four of those need to be carefully monitored by us in the forecast business to make sure the message is clear. I suspect a lot of you have decision making that extends beyond the short term. This is an example of the challenge of making decisions beyond, say, a 3-day forecast. This was Hurricane Laura from last year, and at the time of this forecast, the storm was just beginning to enter the Caribbean. And it stayed pretty much on the center line of this track through the Dominican Republic and Haiti, and then reformed further to the south along the south coast of Cuba. And at day 3 was roughly 75 to 100 miles south west of where the actual forecast was, which is an excellent forecast within the known forecasting skill of the center of a storm. But it's continued on the basic path that was forecast 5 days earlier. And at the 5-day forecast point, which the forecast point was the mouth of the Mississippi, the storm was actually south of southwest Louisiana, where it eventually made landfall. The area highlighted in yellow is the offshore area of the northeast coast of the Gulf of Mexico and many communities along the North Gulf Coast of Florida. On this if this forecast was perfect, the worst impact of this hurricane would be felt in this yellow area in terms of storm surge, high seas, and high winds offshore. But because it tracked further south, this graphic shows the wind field that actually occurred post-analysis, and it shifted further southwest, and they did not even experience tropical storm conditions in the area concerned. But if you have to make a decision in the day 4 and 5, you can't bet on that. You don't know which. There's no bias that you can rely on there. Verification studies show it's just about as likely to be wrong this way as that way off the official forecast. So you have to act as if you're at risk in these conditions. And you have to understand that the probabilities may be kind of low that you'll actually have the impact exactly as forecast. A predecessor of mine used to use the phrase, if you're at risk from a hurricane, for every 3 times you're put at risk by us, 2 times you're going to be wondering, why did you do anything? Because nothing happened. The 3rd time you'll know why. A little bit about the skill in our forecasting. This graphic is a forecast error, and at the time frames of the official forecast, 24, 48, 72, day 4 and day 5. We didn't do day 4 and day 5 till after 2000. In 1990, not that long ago, our average error at the 3-day forecast was 300 miles. Our average error now at day 3 is less than what our average error was at day 1 in 19. It's truly a success story in forecasting to have reduced the margin of error on the track forecast. And we would be in deep trouble given the growth in population along the coastlines if we couldn't forecast better than we did in 1990 that we do today. The improvement trends now on the day 3 and 4 are suggesting that we will be able to expand at day 6 and 7 in the near future. The error changes are mostly linear as we go up into through each day until you get past day 5, in which case it's slightly exponential. Once we get into that linear error, I think we'll go to the day 6 and 7 forecast. Intensity forecast, we're off an average of 10 to 15, and we really haven't made a lot of progress on that. And even more disconcerting is the challenge of forecasting rapid change in intensity. Most storms that reach a major hurricane or category 3 or greater do go through a period of rapid intensification. An example, this was Hurricane Harvey, which is a devastating storm on the Texas coast in 2017. It had been a storm in the Eastern Caribbean. It had opened up to a wave, redeveloped in the southern Gulf of Mexico, and was forecast at that point to make landfall on the Texas coast. Actually as a hurricane, but it was between these 2 forecast points. But anyway, it was a low-end hurricane at the forecast, and the corresponding hurricane watch was issued for it. A day later, it was still a tropical storm with 65-mile-an-hour winds, and in less than 36 hours, it increased to a 130 knot storm just off the Texas coast, where it made landfall as a Category 4. It's very hard sometimes to convince people that they need to do something for a tropical storm at the current conditions. It could be a major hurricane at forecast. Much of the time, this was an excellent forecast. Much of the time, we don't have that much skill at the rapid intensification. In the Gulf of Mexico, there have been 30 storms that have, since 1875, when I have decent data, that have undergone a rapid intensification to major hurricane status. That gives very little lead time for people that operate in the Gulf or have to make decisions on evacuation on land to do so if you're waiting for it to actually do that to make your call. Based on last year's data, it's still less than half of the observed cases of rapid intensification were actually forecast, but in 2010, that was 1 out of 10. We had no skill really at forecasting these. And as we get into the shorter time frames, the skill is better. It's out days 3, 4, and 5. It's almost speculation still. And of course, with the lead times being this long, it's a challenge. Another disturbing trend, and this is in the realm of the climate change folks. I haven't got the expertise in that, but the trends over the last 2 decades has been for an increasing occurrence of this rapid intensification. I've really pretty much covered all this, but just a picture to show the room we have for doing media support and handle decision maker conference calls and the like. It's adjacent to where the hurricane forecasts are. And again, it's mainly tied to when there's a threat of landfall of a hurricane that we're called on to do those. In the U.S., for most of private industry, if it's weather sensitive, it best behooves them to have a contract with a private meteorology firm or have their own in-house expertise. We in the government are pretty much restricted to the products and services that I just showed you to put out, and they may not fit the parameters and timelines, and probably don't in most cases, that are needed by the various and sundry different industries that have the impacts from weather. And nowadays, with the internet and modern high-speed communication, a private weather company can easily afford having access to all the same data that the Hurricane Center does. And my experience with friends that work in that is that they tailor the presentation of the forecast information directly to the operational needs of the client. So it may be different for one set of clients as it is another within the same company. Challenges, forecasting genesis with more skill. If we're going to do a 6 or 7 day forecast, we're going to have to forecast the formation better. I already talked about the rapid intensification. Limits of predictability. Researchers tell me that in some cases they think we're like the short end of the forecast where the errors are down around 25 miles, that we may be hitting a limit of predictability on that part of the science. And in the communication aspects, improving our graphical communication is an ongoing project, and we're still trying to wrap our heads around how to manage all the misinformation that goes out via social media. So with that, I thank you for your time. This is a high-level briefing during Hurricane Ike, President Bush and his staff, and yours truly coming to them from the Hurricane Center on a video conference. Any questions, I'll be glad to oh, what happened here? Hello?
Yeah, Mr. Bill, it was a very nice presentation. Good morning. I am MD Pillai from ONGC Mumbai. I have a series of questions which is related to these cyclones which is occurring in the west coast of India. So recently there was a very devastating cyclone, as you said. I was part of the team which was responsible for cyclone related issues and later on the inquiries and all related activities. Now my first question is, how early we can forecast a tropical cyclone, especially in this northern hemisphere in the Indian Ocean region?
I would think there's some similarities to. I really only have expertise in the forecasting we've done in the Atlantic Basin, but I would think there's similarities on the science end, and the basics that I showed are not that much different. So the science that one would use off the satellites, you use the same numerical models, the global models that are used by the National Hurricane Center are, as far as I know, the same ones used around the globe. At least they were when I was at the Hurricane Center. So we determined that we could give some skill out as much as 5 days. I mean, the models will show you storms out there a lot earlier than that, but the skill is terrible on that. The verification shows a lot of them never materialize or materialize so much different. The decisions that would be made beyond that, most of the time, would be costly.
Bill, my second question is there any defined cyclonic season in this area, Indian Ocean area? See, as I understand, summer solstice is on 20th of June, and from March 20th to September 20th, that is between the two equinoxes, we have the maximum probability of formation of a tropical cyclone in the northern hemisphere.
Yeah.
Can you just relate these two equinoxes with the probability of cyclogenesis in the northern hemisphere, especially in this Indian Ocean region?
Yeah, the last I remember on it was kind of like there were two peaks, one in the late spring, like you saw with the one you had, and then another one in the late fall. And I guess that has something to do with the changes in the monsoon that sets that off. I don't remember seeing any. The place where you would have the official season on that would be from the Indian Meteorological Department. I don't remember seeing that when I looked on their site, the definition of the season. So maybe that you can get them year round, but there are those peaks, I think, in the data.
Yeah, if time permits, I have one more question.
I'm here as long as you guys have questions.
Yeah, as you said, the cyclone, the formation of cyclone starts around 400 kilometers from the equator. That is roughly about 4 to 5 degrees north of latitude. The problem with our operational area is that our fields are located from about 18 degree to 21 degree latitude in the latitude north. So the formation of cyclone, it takes place between 5 to 10 degree latitude, and it initially it forms into a depression, then a deep depression, then cyclonic storm. Even cyclonic storm per se is not a big threat, but if it develops into a severe cyclone or very severe cyclone into a next category, then we will not get enough time to resort to precautionary measures, evacuation, all those things, considering the fact that our operational area is about 100,000 square kilometers.
I sympathize with you. That's why I think one of the holy grails in the tropical meteorology forecasting is to crack the code on what causes in better understanding of what causes these big changes in intensity that allows a storm to rapidly go up to a high end. We sometimes see those on satellite signatures, but like you said, it's too late for you to act. If you haven't acted by then, it's on your doorstep. As far as where they form, it's just they have to be at least that far away from the equator. We have one storm we're working right now that's near Bermuda that formed around 32 degrees north latitude. So the challenge is more on the lower end where they form. And your latitudes you gave me there is kind of the same as the sweet spot over here. A lot of the storms form within that. I don't know I don't know if it's developing like that, but you kind of need what are the probabilities of a storm intensifying and in the realm of something that's going to cause you problems. And I don't know. I got the sense from the few offshore people that I actually know that they do quite a bit, even at the low end of the storm, so that it's not that big a reach to the higher end. They've already done a lot at the lower end storms. Someone's asking a question, but they're muted.
Yeah. It was muted. Now I am muted. Can you please, Mr. Reed? It was very nice, in-depth explanation. And I would like you to focus few things, like for example, key deliverable table process, like SIL, safety integrity levels in various stages. Then HEMP, hazard effect and management plan, like identification, assessment, and control and recovery or rescue, like that. And measure hazard and risk level and control. Yeah, okay. And emergency response plan to be followed. Matrix, it varies from the level of emergency or not, like contingency, maybe level 1, 2, 3, like that. Just please focus in few sentences or one sentence each, and just critical tasks during this, focusing on the hurricane or high-speed cyclones. Okay, thank you.
I think what I understood was the categorizing the response to the strength of the storm. Was that the gist of it? Came in a little broken.
Yes, that's what he meant, Bill.
Yeah. Most of the public agencies that have critical decisions, like for evacuation or staffing up hospitals with extra people and having responders ready, actually have most of them call them stages. So like stage 1 will be we've entered hurricane season, so they're in stage 1 unless something else happens. They'll go to stage 2 when there's a forecast showing a storm in the Gulf within 5 days, and so on. And then they get to the various critical levels when the storm's approaching to make a decision. That way they know what time they need to make their decision. For example, to call an evacuation, when they need to make a decision to bring in extra people for the response phase of the storm and the like. And it's constantly evolving. They learn something new every year that they need to tweak to make the plan work.
Yeah, Bill, I have one question. I am Dinesh Kumar. I was in ONGC. I understand that for some of the hurricanes, the meteorological data were mapped along the route of the hurricane in Gulf of Mexico. Can you share some of it?
Oh, the data we get in the Gulf of Mexico?
Along the route of the when the hurricane actually happened. So along the route of the hurricane, some buoys were installed, some instruments were put up, and then some data was collected. So I mean that might have given you a lot of insight about your predictions.
Those are done by the research aircraft, so they're not always available out there. we have one advantage that nobody else has is that we still fly reconnaissance aircraft, and for operational, a storm in the Gulf, they'll fly it almost continuously, and you will get the actual readings from whatever altitude the aircraft's flying at. Plus, they drop a thing called a dropson that gives them key parameters of pressure, temperature, humidity, and wind, all the way down to just above the surface of the ocean in the path of the storm. There are techniques to retrieve winds from satellite that are get better every year. The surface wind scatterometry is what it's called. To me, it's absolutely amazing that an instrument in space can estimate wind from sea spray, but it does. And the combination of that and the reconnaissance gives us a pretty good feel for not only the strength of the winds, but the extent of it, the aerial coverage of it, which is very important for the storm surge forecast. We also have, and unfortunately, I think we don't have enough, but we have moored buoys, weather buoys out there that also have wave height indicators on them to give us a measurement of the height of the seas. I wish we had more. There's not that many, but they're very expensive to build and maintain.
Thank you. Thank you, Bill.
I again request all the delegates to put their questions in the chat box, or else they can raise their hand. Yeah, we have a question from Tati Pakal, who has joined a session. He has asked, what is the recommended practice followed by the US oil and gas industry for handling hurricanes? Also, what is the general ERP for such situations?
The question about the recommended procedures in the oil and gas industry, your next speaker is probably much better. I don't know. My first response is I've been retired from the business for 9 or 10 years, and I really knew the people offshore better when I was at Houston. So it's been more like 15 years. So I don't really have the answer to that. My guess is there's some variety depending on the complexity of the offshore operation.
Yes, Mike DeVos here. If I may add to that, Mr. Reed, generally speaking, most operations offshore in the Gulf of Mexico, they are time-based scenarios. So in other words, in the early stages of a storm, they begin precautionary watches. When a storm is predicted within 92 hours, 84 hours, certain measures begin to be implemented, evacuation of non-essential personnel, setting of the storm packer, the decision in a subsea scenario, whether to leave the stack on bottom, whether to hang the drill pipe off in a jackup or a fixed platform situation. Decisions have to be made pretty quickly as to laying down the drill pipe and taking other precautionary measures. But generally speaking, those are time-based. Where we run into grave difficulty is that often the operations offshore are plus or minus 150, 200 miles from shore. So when the people in corporate offices are looking at these forecasts and they're saying that it's predicted to make landfall in Houston in 3 days, they think that the guys offshore have plenty of time. And if there's one thing we've learned, the surest way to be late is to have plenty of time. So there's no such thing as having plenty of time, because if you're 200 miles south of land, then obviously decisions have to be made much quicker, and there has to be a coordinated response between the operator and the contractor. Thank you.
Our next question is from Mr. Jayant Malhotra. He's asking, it is a general perception that due to global warming, we might see more cyclones in the western offshore area more often. So what are the precautions we can take and what is your advice on that?
Okay, the gist of the question is if the forecast for the impact of climate change verifies and we have more frequent and more intense cyclones, uh, I'm sure there's some economic issues in there that I'm not expertise on, but I always say whatever we have in the future due to climate change, we have now. It just may be a lower probability that it'll occur. You almost have to prepare for a probable worst case scenario. If you don't, and you get storms stronger than what you prepared for, you're not prepared. So that's basically my advice is that from the safety aspect, you're preparing for the probable worst case.
Next, we have a question from Mr. Sanjay Dobhal. Sir, you may go ahead.
A good day to all. Yeah, I'm Sanjay. I'm look after this deep water operations for ONGC. So it's not question. I'm just sharing one experience. The point in the first slide was seawater temperature on surface. So what we are saying the prediction part, but what is very important is people who are on the field, in the field, their observation. If they observe a very strong thing, so I will just share. In about 2 years back, we have a one rig that is working for us, Olinda Star, and they were struggling. Their engine temperatures were not going down, and they started looking for what is happening with why these engines are not cooling properly. Finally, after doing a lot of analysis, we found the sea surface temperature is very high. When they told us temperature, we were surprised. We never saw temperature like that at surface. So we rechecked it. So that is my point is like what is given in the first slide. Those points are very important. People who are in the field on the location, if they observe things closely, it sometimes will help us to know all these problems coming up much before. Thank you very much.
Next, we have a question from Mr. SK. Next, we have a question from Mr. Sanjay. He's asking, how did the recent cyclone in Indian West Coast and compare that to Katrina in Gulf of Mexico, which caused widespread damage to offshore installations?
I think they were probably of similar intensity. Katrina may have gotten slightly stronger at its peak, and I think Katrina was probably a little bit larger, but once you get up in that category 4 wind speed in the seas it generates, any additional thing doesn't make that much different as far as the impact. Probably from the public side or the land-based impacts on there, it was probably worse for you in India, primarily because you hadn't seen an event like that, whereas Katrina went into a place that periodically gets hit by a major hurricane 2 or 3 times in a generation.
Bill, very informative presentation, and we certainly appreciate that. I did have one other question. Specifically here in the U.S., it seems like you have a wide array of hurricane models. Sometimes 30, television coverage calls them spaghetti models. And these can have wide disparities, 300-400 miles difference in proposed or suggested tracks. Why do you suppose, or can you enlighten us, why are there so many opinions out there? Would it not behoove the public interest to just say, look, we've studied this for the last 5 years. These are the 5 most accurate forecasting models, and we're only going to show these 5 to the public? Because when you have 30 models to look at, you're somewhere between dazed and confused, or at least I am.
I share your pain on that. When I was director, I tried to, I put forth a proposal that we do just what you suggest. At that time, there were 3 or 4 that were the dominant features that we used. And I said, why are we putting out all these others that are known to have more error? And proposal went where there was a tremendous hue and cry from a lot of different sectors that we were withholding information from the public. So, and a lot of those models are some of those models that you see on those spaghetti plots are not run by governmental agencies, so we don't have any control over that anyway. But basically, what I advise people to do is skip looking at that altogether and look at the official forecast, because the hurricane specialists have done the heavy lifting of looking at all the model output and choosing what works best.
Thank you. So we're nearing to the end of this session. May I ask, do we have any final questions?
We still have some questions left in the chat box, so I'll just send them to you. Mr. Colin Johnson said that first of all he had 2 things to say. One is an observation that the offshore operations with the 4-stage hurricane preparedness approach works very well for the storm approaches. From an operations point of view, he can recommend this approach. It works well. The second is related to US issues, that there has been a formal decision to tone down the local coverage in relation to these storms. We have noticed and believe that this is a great help for people to make this decision.
Yeah, this is an observation rather than a question.
Next, we have Mr. S. Karunanidhi. He asked that, do you recommend online monitoring systems for waves, wind and current for your operational area?
Oh, okay. That's a good point I didn't bring up. One of the things when I teach hurricane preparedness, especially for people that are critical decision makers, is that you really ought, since weather is so important to your operation, it behooves one to become an amateur meteorologist, which means keeping up with the weather fairly continuously. At a minimum, the first thing you should do in the morning is check your forecast information and see if there's anything in the near term that might disrupt your activities for the day. And then when it comes to a tropical threat, since the forecasts are issued every 6 hours, be aware of those times and be on the lookout for the latest information on that, and compare that to what you were preparing for so that you know what changes are coming up.
I guess that's it, sir. We only had these many questions. Thank you so much for the amazing presentation. I would like to request Mr. Arun Kale to kindly come up and give the vote of thanks.
Well, good evening, everybody. Man, what a fantastic webinar. Phil, you did a fantastic job.
Thank
and
you.
we really appreciate coming all the way 12,000 miles away down over here and talk. I often say that our drilling industry is going to. We have over 200 participants. We had over 200 participants, and both. If I can talk and if others can go on a mute, or if somebody else wants to talk, that's fine with me. So I'll continue. We had more than 200 participants, and again, Bill, you've done a fantastic job. We really appreciate it, and I keep on saying, one of these days we drillers going to get so good that we're going to make a hole right from Houston into Bombay, so that will be very fast travel going from one end to another end. And now we're doing all these geothermal bases. So I think one day we're probably going to do it. But anyway, my job right now is to thank the folks. So first of all, I want to thank Mr. O.P. Singh, our chairman, for giving his time and attending the entire webinar. We kind of got him at the last minute, and I also need to thank oh, I need to thank also Mr. Madhavan. In fact, he was the driver who pushed me to get into this as soon as possible, as well as Mr. Ajay Dikshit from ONGC side. I had a lot of help from Mr. Arun Jaiswal, Mr. Pillai, Mr. Mahapatra, who helped us to get all the people together and to get them invited. And of course, Rishi and Vidhi, you girls have done a fantastic job. Got to thank you. And most important person I need to thank is Mr. Mike DeBose. Mike, without you, we couldn't have done this. And I've been talking to Mike before he goes to sleep in the night when I get up, so we used to do twice a day communicating. And Mike, I certainly appreciate it. You are the ambassador over here to IADC ACA chapter to keep us going. I also want to thank our IADC ACA chapter, Mr. Patnaik, Mr. Gurpreet Sara, Narendra Jindal for all their support. And two more other important people I want to thank is my secretary Shobha and Akshay, who's our IADC intern who put all these package together. And I think we did a right decision to have only one speaker today. If I'm looking at it, yes, we've 4 minutes short of 90 minutes. And we also have a second speaker next time, which we dropped this time, Mr. Cliff Mead. And Cliff has got a lot of actual practical experience. He has handled over 600 cases of platforms recovery, which had gone over into the Gulf of Mexico in Rita and Katrina. So that second webinar we trying to get, say, 2 weeks from now. Right now, I'm looking at tentative date of 2 weeks from now, 31st August. But we will reconfirm and we will again send the invite and tell what it is. And I would like to hear all the constructive criticism from all the folks who attended. And again, I have to thank all the 200 folks who attended. And good night from my side. And thank you very much again for everybody. Good night.